Okay, back on brain cancer. The second leading cause of cancer-related deaths in people under 20. Number one cause of death for children under 14, brain and NCS tumors. 15 to 19, 2 or 3 depending on the year for number one cause of death. Those are 2 to 3 depending on the year. American Cancer Society and CDC mortality data confirms this general thread.
But that's not all we wanted to do.
No, but I think that's a very big deal. That is effectively how you will RL things in the future. Is you design a technology when tested against the laws of physics, does it work? Or can you if it's discovering new physics, can it come up with an experiment that will verify the physics, the new physics? So I think that's really the fundamental RL test. The RL testing in the future is really going to be your RL against reality. Because you can't. That's the one thing you can't fool physics.
Right, but you can fool our ability to tell what it did with reality. If you think
humans get fooled as it is by other humans all the time.
That's right. So what is?
If people say like, what if the AI tricks us and do something actually other humans are doing that to other humans all the time.
Well, you're pointing out it's like even harder.
Propaganda is constant. Every day another psyop, Today's psyop will be like Sesame Street psyop of the day.
What is XAI's technical approach to solving this problem? Like, how do you solve reward hacking?
I do think you want to actually have very good ways to look inside the mind of the AI. So this is one of the things we're working on, and Anthropic's done a good job at this, actually being able to look inside the mind of the AI. So effectively developing debuggers that allow you to trace as fine a grain as to a very fine grain level, to effectively to the neuron level if you need to, and then say, okay, it made a mistake here. Why did it do something that it shouldn't have done? And did that come from bad pre-training data? Was it some mid-training, post-training, fine-tuning? Some RL error? Like there's something wrong with that. With it did something where maybe it tried to be deceptive, but most of the time it does something wrong. It's a bug, effectively. So developing really good debuggers for seeing where the thinking went wrong, and being able to trace the origin of the wrong thing, of where it made the incorrect thought, or potentially where it tried to be deceptive. Is actually very important.
What are you waiting to see before just 100xing this research program? Like XAI could presumably have hundreds of researchers who are working on this.
We have several hundred people who, I prefer the word engineer more than I prefer the word researcher. There's most of the time, what you're doing is engineering, not coming up with a fundamentally new algorithm. I somewhat disagree with the AI companies that are C corps or B corps trying to generate profit as much as possible, or revenue as much as possible. Saying they're labs. They're not labs. Lab is a sort of quasi-communist thing at universities. They're corporations. let me see your corporation documents. Oh, okay, you're a B or C corp, whatever. So I actually much prefer the word engineer than anything else. The vast majority of what will be done in the future is engineering. It rounds up to 100%. Once you understand the fundamental laws of physics, and not that many of them, everything else is engineering. So then what are we engineering? We're engineering to make a good mind of the AI debugger to see where it said something, it made a mistake, and trace the origins of that mistake. So just you can do this obviously with heuristic programming. If you have like C++, whatever, step through the thing, and you can jump. You can jump across whole files or functions, whatever subroutines, or you can eventually drill down right to the exact line where you perhaps did a single equals instead of a double equals, or something like that.
Yeah.
Figure out where the bug is. It's harder with AI, but it's a solvable problem, I think.
You mentioned you like Anthropic's work here. I'd be curious if you
Well, I don't know everything about Anthropic.
Sure.
Shelter.
What? Yeah.
Also, I'm a little worried that there's a tendency. So I have a theory here that if simulation theory is correct, that the most interesting outcome is the most likely, because simulations that are not interesting will be terminated. Just like in this version of reality, on this layer of reality, which if a simulation is going in a boring direction, we stop spending effort on it. We terminate the boring simulation. So
this is how Elon is keeping us all alive. He's keeping things interesting.
Yeah. Arguably, the most important thing is to keep things interesting enough that whoever's paying the bills on what some
wants to see the
cosmic AWS.
They're renewed for the next season.
Yeah, are they going to pay the cosmic AWS bill, whatever the equivalent is that we're running in? And as long as you're interesting, they'll keep paying the bills. But there's like, if you consider then say a Darwinian survival applied to a very large number of simulations, only the most interesting simulations will survive, which therefore means that the most interesting outcome is the most likely, because only the interesting, like, would either that or annihilated. And so, they particularly seem to like interesting outcomes that are ironic. Have you noticed that? That how often is the most ironic outcome the most likely? Now look at the names of AI companies. Okay, Midjourney is not mid. Stability AI is unstable. OpenAI is closed. Anthropic, misanthropic.
What does this mean for X?
Minus X, I don't know. It's I intentionally made.
Why?
Yeah, it's a name that you can't invert really. It's hard to say what is the ironic. What is the ironic version? It's a, I think, largely irony-proof name.
By design.
Yeah. you gotta have an irony shield.
What are your predictions for where AI products go? In that nice sense of, you can summarize all AI progress into, first you had LLMs, and then you had kind of contemporaneously both RL really working and the deep research modality, so you could kind of put in stuff that wasn't in the model. And the differences between the various AI labs are smaller than just the temporal differences, where they're all much further ahead than anyone was 24 months ago or something like that. Yeah. So just what does 26, what does 27 have in store for us as users of AI products? What are you excited for?
Well, I think I'd be surprised by the end of this year if digital human emulation has not been solved. I guess that's what we mean by like the sort of macro hard project is can you do anything that a human with access to a computer could do? Like in the limit, that's the best you can do before you have a physical Optimus. Mm-hmm. The best you can do is a digital Optimus. So you can move electrons until you can amplify the productivity of humans. But that's the most you can do until you have physical robots. That will superset everything. Is if you can fully emulate humans.
This is the remote worker kind of idea. where you'll have a very talented remote
Well,
worker.
you can sort of say in the limit. Like physics has great tools for thinking. So you say in the limit, what is the most that AI can do before you have robots? And it's anything that involves moving electrons or amplifying the productivity of humans. So digital human emulator
Yes.
is in the limit. Human at a computer is the most that AI can do. In terms of doing useful things before you have a physical robot. Once you have physical robots, then you can then you essentially have unlimited capability. Physical robots, I call Optimus the infinite money glitch because
You can use them to make more Optimuses.
yeah, you see like humanoid robots will improve as will basically be three exponentials. Three things that are growing exponentially multiplied by each other
Yes.
recursively. So you're going to have you have exponential increase in digital intelligence, exponential increase in the chip capability, AI chip capability, and an exponential increase in the electromechanical dexterity. The usefulness of the robot is roughly those three things multiplied by each other. But then the robot can stop making the robots. So you have a recursive multiplicative exponential. This is a supernova.
And do land prices not factor into the math there, where like labor is one of the four factors of production, but not the others? And so, like, if ultimately you're limited by copper or pick your input, just it's not quite an infinite money glitch because
Well, infinity is big. So
Yeah.
no, not infinite, but
Yeah.
But let's just say you could do many orders of magnitude of Earth's kind of current economy. Like a million.
Yeah.
So this why. So, if you, just to get to let's say I think just to get to a millionth, a harnessing length of the sun's energy would be roughly, give or take an order of magnitude, 100,000 times bigger than Earth's entire economy today.
Mm-hmm.
And you're only at 1/millionth of the sun. Give or take an order of magnitude.
Before we move on to Optimus, I have a lot of questions on that, but
Every time I say order of magnitude, I say.
you're gonna drink 10 drinks.
I'm gonna take a shot every time I say that to
You're
him.
gonna 10 the next time, 100 the next time after that.
Yeah, well, order of magnitude more wasted.
I do have one more question about XAI. This strategy of building a digital or remote worker, co-worker
Yeah,
replacement.
which everyone's
is-
going to do, by the way, not
yeah.
just us.
So what is XAI's plan to win?
You expect me to tell you on a podcast?
Yeah.
Spill all the beans. Have another Guinness.
It's a good system.
People sing like a canary. All the secrets, but it's just
Okay, but in a non-secret spilling way, what's the plan?
What a hack.
well, when you put it that way, I think the way that Tesla solved self-driving is the way to do it. So I'm pretty sure that's the way.
Unrelated question. How did Tesla solve self-driving? Yeah. It sounds like you're talking about data, like Tesla self-driving because of the.
And we're gonna try data and we're gonna try algorithms.
But isn't that what all the other lines are trying? Like what's?
And if those don't work, I'm not sure what will. We've tried data. We've tried algorithms.
I'm all out of it.
We've run out of it. No, we don't know what to do. I'm pretty sure I know the path, and it's just a question of how quickly we go down that path. Because it's pretty much the Tesla path. I mean, have you tried self-driving, Tesla self-driving lately?
Not the most recent version, but
Okay, the car is like, it just increasingly feels sentient. Like it feels like a living creature. And that'll only get more so. I'm actually thinking like we probably shouldn't put too much intelligence into the car because it might get bored and
start running the streets.
I mean, imagine you're stuck in a car and that's all you could do. You don't put Einstein in a car. It's like, why am I stuck in a car? So there's actually probably a limit to how much intelligence you put in a car to not have the intelligence be bored.
What's XAI's plan to stay on the compute ramp of that all the labs are doing right now? The labs are on track to spend over like $50 to $100 million.
The corporations.
sorry. Yeah, corporations.
The labs are at universities, and they're really like a sale.
They're not spending $15 million.
The revenue maximizing corporations.
That's right. But the revenue maximizing corporations
that call themselves labs
are making like 20 to 10 billion, depending. Like OpenAI is making 20B revenue. Anthropic is like 10B.
Close for maximum profit. Yeah.
XAI is reportedly at like 1B. Like, what's the plan to get to their compute level, get to their revenue level, and stay there as things get
Yeah. So as soon as you unlock digital human, you basically have access to trillions of dollars of revenue. In fact, you can really think of it like the most valuable companies currently by market cap. Their output is digital. NVIDIA's output is FTPing files to Taiwan. it's digital.
Right.
Now those are very, very difficult to...
high value files.
They're the only ones that can make files that good. But that is literally their output. They FTP files to Taiwan.
Do they FTP them?
I believe so. I believe that is the
SFTP.
file transfer protocol. I believe is I could be wrong, but either way, it's a bit stream going to Taiwan.
Yeah.
Apple doesn't make phones; they send files to China. Microsoft doesn't manufacture anything, even for Xbox. That's outsourced. Their output is digital. Meta's output is digital. Google's output is digital. So if you have a human emulator, you can basically create one of the most valuable companies in the world overnight, and you would have access to trillions of dollars of revenue. It's not like a small amount.
Okay, I see. You're saying basically like revenue figures today are just like so like they're all rounding errors compared to the actual TAM. So just like focus on the TAM and how to get there.
I mean, if you take something as simple as, say, customer service, if you have to integrate with the APIs of existing corporations, many of which don't even have an API, so you've got to make one, and you've got to wade through legacy software, that's extremely slow. However, if AI can simply take whatever is given to the outsourced customer service company that they already use, and do customer service using the apps that they already use, then you can make tremendous headway in customer service, which is, I think, 1% of the world economy, something like that. It's close to $1 trillion all in for customer service, and there's no barriers to entry. You can just immediately say, well, we'll outsource it for a fraction of the cost, and there's no integration needed.
You can imagine some kind of categorization of intelligence tasks where there is breadth, where customer service is done by very many people, but many people can do it. And then there's difficulty, where there's a best-in-class turbine engine. Like presumably there's a 10% more fuel-efficient turbine engine that could be imagined by an intelligence, but we just haven't found it yet. Or GLP-1s are just a few bytes of data. Where do you think you want to play in this? Is it a lot of reasonably intelligent intelligence, or is it the very pinnacle of cognitive tasks?
Well, I was just using customer service as like something it's a very significant revenue stream, but one that is probably not super difficult to solve for. So if you can emulate a human at a desktop, that's just literally what customer service is, it's people of average intelligence. It's not like you don't need like somebody who's spent many years. You don't need like sort of several sigma good engineers for that. But obviously, as you make that work, you can then, once you have computers working, effectively digital optimists working, you can then run any application. Like let's say you're trying to design chips, so you could then run conventional apps, like stuff from Cadence and Synopsys and whatnot, and you can say you can run 1,000 simultaneously or 10,000, and say, okay, given this input, I get this output for the chip, and at some point you can say, okay, you're actually going to know what the chip should look like without using any of the tools. So basically, you should be able to do a digital chip design. Like you can do chip design. Like you watch up the difficulty curve. You could be able to do CAD. So you could use like sort of NX or any of the CAD software to design things.
Okay, so you think you started the simplest tasks and walked your way up the difficulty curve.
So you're saying, look, as a broader objective of having this full digital coworker emulator, you're saying, look, all the revenue maximizing corporations want to do this, XAI being one of them, but we will win because of a secret plan we have. But like everybody's like trying different things with data, different things with algorithms, and I'm like,
I like that.
Like, what is
tried data. We've tried algorithms.
Plan?
What else can we do?
But
yeah,
like, it seems like a competitive field, and I'm like, how are you guys gonna win? Is like my big question.
I think we see a path to doing. I mean, I think I know the path to do this because it's kind of the same path that Tesla used to create self-driving. Instead of driving a car, it's driving a computer screen. So it's a self-driving computer, essentially.
Oh, you're saying is the path just following human behavior and training on vast quantities of human behavior?
Wait, but sorry, isn't that? I mean, isn't that training?
I mean, obviously, I'm not going to spell out, most sensitive secrets on a podcast. So, I need to have at least 3 more Guinnesses for that.
I've got some friends at Jade Street, and they're always talking about how their colleagues are cooking up fun, fiended.
Is that,
Is it going to be,
Well, those layers went in, and so I had to figure out the correct order using the outputs of the original 122 permutations. So clear.
Those GPUs don't pay for themselves.
Exactly. But yeah, what's the business model? What are the revenue streams in a few years' time?
I think things are going to change very rapidly. Like, I'm stating the obvious here. I call AI the supersonic tsunami, a level iteration. So, really, what's going to happen is, especially when you have humanoid robots at scale, is that they will make products and provide services far more efficiently than human corporations. So amplifying the productivity of human corporations is simply a short-term thing.
So you're expecting fully digital corporations, rather than like SpaceX becomes part AI,
I think there'll be digital corporations, but some of this is going to sound kind of doomerish, okay? But I'm just saying what I think will happen. It's not meant to be doomerish or anything else. Just like this is what I think will happen.
We're going to leave it right there, and we're going to do another part so I don't run out of data this time.